All right. So, welcome to my presentation for Psychology 4390N, Psychopharmacology with Professor Farley. So today I'm going to be talking over N-BOMe compounds. So this is a brief overview of substituted N-benzyl phenethylamines, presented by myself. So, give you a little background on the general chemistry of these compounds. This right here, we have phenethylamine. This is the backbone of a huge array of chemicals with a variety of different uses across all sorts of fields of medicine, chemistry, psychopharmacology, all kinds of things. So right here, you can see the phenethylamine. This is a phenyl ring. 2-carbon chain is called a ethyl chain. And then any kind of nitrogen you have in an organic compound, that's called an amine. So you put those together, you get phenethylamine, thus the name. So here is just a couple of examples of compounds with phenethylamine backbones. So here we have albuterol, very common asthma medication. It helps to dilate the lungs and the bronchial tubes to help alleviate any form of, not being able to breathe. Here we have dopamine, just an endogenous neurotransmitter, very common across the animal kingdom. We've learned about it a lot in this class. Then over here we start getting into the more interesting things, more applicable to psychopharmacology. So here we have amphetamine. It's probably one of the simplest modifications you can make to this phenethylamine backbone. That's going to have some form of psychopharmacological effect. So you can see it just added a carbon right here to the alpha position of the phenethylamine backbone. Here you've got bupropion, common antidepressant known as Wellbutrin. But you can still see we got the phenyl ring, ethyl chain, nitrogen, making it a phenethylamine. MDMA, maybe one of the best known of the, entantogenic or psychedelic phenethylamines. Same thing, phenyl ring, ethyl chain, nitrogen, still phenethylamine. Another example, we got cathinone, very simple deviation from the phenethylamine backbone. But you've got this beta keto group and a alpha methyl group. This is found naturally inside of the cat plant, and it's used in areas it's grown as just like a common stimulant. And there's a lot of other analogs you can make from the cathinone kind of structure, but that's its own presentation on its own. So we're going to get into the N-benzyl phenethylamines. So an N-benzyl phenethylamine is the same thing as a phenethylamine, but it is going to have this N-benzyl group right here. So here we have phenethylamine, but attached to the nitrogen, we've got a benzyl group. So same thing, just with this N-benzyl substituent. So the most known class, or the most known chemical from this class of compounds, is the 25I-N-BUME compound. These you just kind of broadly call them the N-benzyl phenethylamines, but the bulk of this presentation is going to be about 25I-N-BOME. So get you a little bit of background on 25I-N-BUME. The full IUPAC name is 2,4-iodo-2,5-dimethoxyphenyl N2-methoxyphenyl methylethanamine. So it's a huge mouthful, but the IUPAC nomenclature system is just a way that we can name chemicals across the entire world. So if I go to a country that a chemist doesn't speak English in, I can say that name to them and they'll know exactly what I'm talking about. So that's a good system. So this 25I, it was first synthesized in 2003 by a German chemist named Ralph Heim. He was working on his PhD thesis, and he was specifically looking into the effects of high-potency agonists to the 5-HT2A receptor, and that's a receptor that's known for its, the psychedelic effects of a variety of chemicals. So he wanted to see what, super strong agonism was going to do. So he developed this chemical, which, as we'll see later, is a very potent agonist of that receptor. So later research was conducted by David E. Nichols in 2008 at Purdue University. David E. Nichols is the foremost expert in the United States about psychedelics. He has built his entire career as a medicinal chemist around the research of psychedelics and their pharmacology and societal impact and all sorts of things. And mainly the reason we know about 25I, or even talking about it, is that it began being used in a recreational setting around 2010. So various suppliers online were selling it as a quote-unquote legal high. And we can see here in this picture, we've got 10 blotters that contain 25I. Actually, in this example, it is 25I. But as you can see, the top on that label, it says not for human consumption. So they could sell it, say, don't eat this, but the real intention was for people to consume it. But they were able to bypass a lot of laws that way. So let's go a little bit into the pharmacology here. So like I said earlier, 25I is a highly attractive option for researchers when they're investigating the 5-HT2A receptor. So if you noticed on the molecular structure, there's an iodine molecule, or an iodine atom. What they can do is they can replace that with a radio-labeled iodine, and when the drug is administered to an animal, that radio labeling will be able to be detected by various scanning methods, and you can see how the drug is distributed throughout the whole brain. So if you go over here at some of the inhibitory constants of various psychedelics, so for 25I, 5-HT2A is what we're really concerned with. It's got an inhibitory constant of 0.044, so the lower the number, the higher of an agonist it is, or more tightly bound it's going to bind to that receptor. If we compare that to 2CI, which is the parent compound of 25I, it's going to be 17, so pretty big jump between those two. And then if we just compare that to LSD, 2.9, still pretty low, but nowhere near as low as this 25I number is. So down here it says, we got a 25I displays a 385 times higher binding affinity, I guess lower number, but it's going to bind a lot tighter to that receptor than the parent molecule of 2CI. And that's what makes it such an attractive option for researchers who are specifically trying to learn about the serotonin receptors in the brain. So we get a little bit into the recreational use. This image, this is a possible depiction of what 25I visual distortions look like. I guess this could be applied to really any psychedelic, but that's a general idea. So 25I is predominantly consumed on blotter paper, or what you would just call tabs, I guess as a slang. So it's just a tiny piece of paper that the substance has been dissolved into on the paper. So then you put it in your mouth, put it into your tongue, and that way you're going to take the drug sublingually, and it's going to absorb into your body that way. Tabs advertised through various markets. They're going to say that between 300 and 1200 micrograms, averaging at about 800 micrograms, which is a pretty strong dose of this drug. Really 300 to 500 is a generally safe dose. Not a lot of issues are going to happen there, but bang for your buck, they're going to get 800 out of it. So for most users who are approaching this drug, they're looking for visual distortions and stimulation. So when this drug became a little bit popular in the kind of EDM or electronic music scene, people wanted to, dance all night, have all the eye candy, and have a good time. So that's why people were looking for this drug specifically. So in a lot of ways, this drug is comparable to a lot of classical psychedelics, LSD, psilocybin, mescaline, that kind of thing. But one issue with 25I is you're going to have a lot more negative physical side effects than those other drugs. A lot of people experience pretty alarming vasoconstriction, so they're going to feel really cold and clammy. They might lose sensation in the extremities. A lot of people will experience a fever. Overheating is really common, and that can lead to some serious problems down the line. NBOME compounds are said to cause a little bit less introspection or profound thinking than the other classical psychedelics like LSD, which for some people, it's a really big advantage because they're there for the eye candy, the physical sensations, at least the pleasant physical sensations, and the stimulation. But some people, when they use psychedelics, they're there to look deeper and introspect, and you're not going to get that with this class of drugs. So like I said, most people take this sublingually on blotter paper or tabs. There are a few self-reported instances of vaporization or insufflation, snorting. One report from user Antibody2 on the Vespri forum, he actually made a freebase solution of 25B NBOME, which is a slight analog using a bromine atom instead of iodine, but in terms of subjective effects, they're very comparable. And he actually vaporized that compound out of a bulb, we probably colloquially called as a meth pipe. So he vaporized about 400 micrograms with concurrent consumption of 400 milligrams of MDMA and an unknown dosage of vaporized DET, or diethyltryptamine, and it resulted in an unpleasant experience. Unsurprisingly, he turned his body pretty much into a science experiment, and it resulted in his arrest, and he was put in hospital for a while. So, probably could have told you that was going to happen before he even did it. So doses over 200 micrograms or 2 milligrams can cause some serious health complications, as we'll see later. It won't end up well, generally, at those doses. Seizures are common. People will thrash and hit their heads. Overheating is common. People will vomit and then choke on their own vomit. So that's where a lot of the stigma from this drug comes from, is the deaths it caused. So we'll see here, once 25I really hit the streets as a legal high, it was very easy to get. You would just pay. You could pay with credit card, pay with PayPal, stuff like that, and you could get it delivered straight to your house. You get a lot of it for really cheap. So that was very tantalizing to a lot of people. They say, oh, I can't really get LSD, I can't get these other things, we'll try this out. So 25I has been associated with at least 19 deaths in the United States. And I say at least because, we have other deaths that 25I may have had implications in. But we're going to know this has been confirmed at least 19 deaths. So these deaths have caused a response from law enforcement, specifically the DEA, and they made 3 of the analogs, 25I, 25B, and 25C, all Schedule 1 controlled substance in 2003. So they were all the exact same molecules, the only difference being 25I has an iodine, 25B has a bromine, and 25C has a chlorine, all in the 4th position of the primary phenyl ring. But they're all really comparable in effects, and the synthesis is going to be very similar across the board for those. So we hear all these horrible things, and we have all this news hysteria, and people ask, why would anyone, choose to take this drug? And the thing is that when 25I had its peak of use, purposeful use was somewhat rare. People weren't really choosing to go out and they say, oh, today I'm gonna take 1,500 micrograms of 25I NBOMe. It does happen. That wasn't the bulk of why people were using it. The reason people were using it was because street dealers were either laying the blotter paper or getting a hold of blotter paper of 25I and selling it off as LSD. So the thing about that was, if a lot of the deaths were associated with teenagers. If you're a teenager in 2013, you're not going to have the analytical equipment to fully tell if what you have in your hand is 25I or if you actually have LSD, which is what you were looking for. So these drug dealers were passing it off and saying, here's some LSD. In reality, it was one of these NBOMe compounds. So that kind of became a trope in the LSD community, as you can see on this t-shirt right here. If it's bitter, it's a spitter. 25I is known for having a particular metallic taste, and with LSD, you're really not going to have any taste at all. So if you put a tab in your mouth and it doesn't taste right, just spit it out. It'll be, safer in the long run. At regular doses of, say, 300 to 600 micrograms, 25I can be perfectly safe. It can be enjoyed, and a lot of people have reported really great experiences with it. The problem is, it's pretty easy to take a much higher dose than you were anticipating. So if you're handed LSD, or what you think is LSD, you're handed 10 pieces of blotter paper, 10 tabs, and you take all of them, assuming it's LSD, 10 tabs of LSD, you might have a not pleasant experience psychologically, but physically, you're going to be pretty safe. You're not going to have serious toxic effects, your organs aren't going to shut down, you're not going to have a seizure. But when people don't know what they're taking, if they take 10 tabs of an NBOM compound, they could very easily die. Say it's 800 micrograms per tab, and they just took 8 milligrams, that can cause some serious problems. So you might ask, why were people selling fake LSD? And that's a pretty easy answer. The answer was profit. It was extremely profitable to sell any of the NBOM compounds off as LSD. The profit margins were insane. So much more money to be made doing this than actually selling what you say you're selling. So we look at a profit incentive from a production standpoint. Don't even look at it as you are a street dealer and you're just trying to make some money from teenagers who don't know what they're taking. So that bottom image we see right there, that is ergotamine, and that is really the only utilizable precursor you can make to make LSD. There's a couple others. You could start with just the unsubstituted amide, but that's going to have its own issues. The only thing you could get really large quantities of would be ergotamine. But the problem with that is that ergotamine is extremely monitored by pretty much every government in the world. You're going to have to know some serious people if you want to get your hands on, a reasonable quantity of ergotamine. So ergotamine on the black market could sell from anywhere to $600 to $1,500 per gram. And that sounds like a lot, but say you're able to get 500 milligrams of LSD out of it, and you do tabs that are 100 micrograms per tab. So for every milligram, you can get 10 tabs. Every gram, you can get 10,000 tabs. So 5,000 tabs of acid for $1,500 is a pretty good deal in the eyes of a producer. And not only are you going to have the resources to do this, you're going to have some serious experience in thin layer chromatography, column chromatography, and highly sensitive coupling reactions. That ergotamine and lysergic acid and LSD itself are all very sensitive compounds. They're sensitive to light, they're sensitive to heat, acids, bases. You don't have to be an expert necessarily, but you have to have a pretty good idea of what you're doing. And overall, it's going to cost probably $1.40 per dose to produce. So each tab, the production side, is going to cost about $1.40. We'll look at 25I and BUME. On the other hand, that top image right there, 2,4-dimethoxybenzene, that could be your starting material for making an N-bomb compound. If you just have a visual comparison between the two, and you don't even know anything about chemistry, you would probably be able to tell that 1,4-dimethoxybenzene is going to be a little bit easier to find than ergotamine. So if you were to synthesize 25I, every single chemical you would need could be purchased with very, very little suspicion in a store. You could just go to a storefront and buy it, or online. Versus ergotamine, you're going to need a coupling reagent, which is already hard to find regardless of LSD synthesis. You're going to need ergotamine itself. Really not going to find that. And then the diethylamine, which again is an extremely monitored chemical. But this dimethoxybenzene, it is a very common perfumery chemical. So a lot of places will sell it to make perfumes. It has kind of a oaky, almost like hay smell to it. You can buy it online right now, 500 grams of it for $145. So 500 grams for $145 versus $1,500 for 1 gram, that's a little bit of a no-brainer. So based on my estimations, you could probably produce a dose of 25I for about half a cent per dose, and that makes it roughly 280 times cheaper than LSD to produce. But say you sell them for the same price, $10 for a hit of acid or $10 for a hit of 25I, you've just increased your profit margins by 280 times. So this is a possible reaction pathway you could do to prepare 25I. And if you are familiar with organic chemistry, you can see that all of these reactions are very, very simple to make. And I drew this out, and the percentages you see there are the percentages you could expect to get in yield. So see right here, you're going to get about 67% conversion, 45, 78, so on and so forth. But if you think about it, 1, 2, 3, 4, 5, it's only 5 reactions to get where you need to go. And none of these reactions are very sensitive at all. They can be done pretty sloppily, and you're still going to get something out of it. So if we assume that it costs $2,000 for all of your chemicals and all of your equipment, which is an overestimation, you could do it for a lot less. One person, say you start with 500 grams of the starting material, like we said earlier, would cost about $145. One person, in about a week, with very little knowledge, could produce approximately 270 grams of this 25I compound. So if you were to lay blotter of this compound at 800 micrograms per dose, 270 grams would produce 340,000 doses, which is a whole lot. And if you were to sell it at a wholesale price of $3 per dose, you're going to make $1 million. So your $2,000 investment just turned into $1 million. And of course, there's a lot more work involved with that of selling 340,000 doses of a drug that people don't actually want to take. But that was a general idea of why it became so prevalent. So this class of drugs, I've referred to it as a Hydra class of compounds because the DEA, they made 25I, 25B, and 25C Schedule 1 compounds. And that's only 3 of them. But if we look here, these are all positions where you could add a substituent going from 1 to 13. So there's 13 spots you could add a different functional group. So just assume you could do fluorine, iodine, chlorine, bromine, methoxy, ethoxy, methyl, ethyl, nitro, methylthio, and ethylthio. And that is not an exhaustive list. There's a lot more you could do with just that. But for an example, you got 11 substitutions on 13 possible locations. You're going to have 13 to the power of 11. Not to the power of, to the power of 11 possible configurations of NBME analogs, which is going to be 1.7 times 10 to the 12th, which is a lot of different compounds. And this is a massively lower bound estimation. There's a lot more you could do with it, but this is just an example to show you how big of a number this is. This example, what you can really see here is that prohibitionist laws are always going to be one step behind recreational drug industry. Law enforcement can only respond to things that are happening. They can take preventative measures, but they're not going to catch up. So that profit incentive is so strong that people will find something else. So there is this number of compounds. Not all of them are going to be psychoactive or have desirable effects. Some of them may just kill you instantaneously. We don't really know. But say that even, 0.1% of these could be sold off as another drug. That's still a huge, huge number of compounds. So this is an example of some other NBOM analogs that have been produced and researched. This was taken from this research paper right here. And this is just, you got 12 right here. And only this one, 25I, 25C, and then 25B have been made illegal. So, what are we going to do? There's so many of these can be made, and these are all just simple substitutions. So, in this next slide, I'll show you some examples of some theoretical NBOM compounds that we could make. These I just made up, and I drew them in ChemSpider, and they look really wacky, but it really exemplifies the point that there are so many things you could do to this simple backbone that there's no way anyone can catch up, and this is a problem that will continue to go on, and issues will be caused because that's why I called it the Hydra. You're going to outlaw one, 10 more are going to be discovered and take its place. And we saw the same thing with fentanyl, because now there's over 10,000 known fentanyl analogs. The profit incentive on these things are just too high. People are going to continue to do it no matter what. So for a summary, like I said, the N-benzyl phenethylamines, extremely diverse group of compounds. A lot could be done with them, and the issue with the prohibition of what already happened is we've lost out on a lot of research that could be done. There's a lot of things that we could learn about them that now people can't really do because you're going to have to jump through a lot of hoops through the US government in order to just be able to research these things. They were first invented for research. They were never invented to be used at the recreational level. It was not the intention of Ralph Heim or David Nichols. They wanted to just purely learn more about the human brain. But, as we already saw, it did find use in recreational settings. It was passed off as LSD due to users being unable to know what is actually put on the blotter paper. And that's where the whole "if it's bitter, it's a spitter" phrase came from. And that's one way to know, I suppose. And there is something to be said for qualitative analysis of chemicals. These drugs cause some health issues in some users, That's what led to the scheduling of these drugs. People did die, and it's terrible, and these issues could have been avoided. NBOEs are significantly easier to produce than other psychedelics with a much higher profit margin. Like I said, you're going to have to know a thing or two about chemistry to make LSD, and you're going to have to know some people to get your hands on these chemicals, versus 25I. If anyone desired, they could go ahead and just do it. And that's what made these chemicals such a tantalizing option for street dealers to make even more money. I mean, the markup on most drugs is already astronomical, but, why not make 280 times more money like we saw with 25I? All right, here are my references, and that is all I have for you. Thank you for joining me, and I hope you have an excellent rest of your day.